Lesson 5-8, Rational Zero Theorem. Objective, identify possible rational zeros of a polynomial function. Find all the rational zeros of a polynomial function. The rational zero theorem says that if you have a rational number as a zero, then you're going to be able to find it right here. It'll have this form, P over Q, where P is a factor of the constant term and Q is a factor of the leading coefficient. So P over Q, we're going to be able to find, it'll be a factor of 40. There's all kinds of factors of 40, and a factor of 6 for the denominator. So these kind of combinations here. And you can see this is a 0. They told us a 0, and it is a reflection of the numerator is a factor of 40, and the denominator is a factor of 3. And then we also have 4 as a factor. Again, 4 is a factor of negative 40, and plus or minus 1 is a factor of the denominator, and so on. Now the corollary says that if your leading coefficient is 1, P over Q, remember P represents factors of 12, and since Q is factors of the leading coefficient 1, we end up really just looking at these factors of 12, because when you divide by 1, you don't change anything. Let's take a look at a problem that's done for us. Notice that these are factors of 16. All these are factors of 16. These are all factors of Q, and now we want to find all the combinations. So we'll first use this as our denominator. When we use this as our denominator, we're going to get every one of these when we put in the denominator. Now, when we use this as our denominator, we're going to get a plus or minus 2, 1/2. But when we put it under here, we're going to get a 1, 2, 4, and 4, which we already have here. Now, if you use this as your denominator for all the possibilities, you're going to get a plus or minus 1/4. But if you put it right here, we're going to already get that plus or minus 1/2, 1, 2, and 4. All right, on the B problem, we're going to find factors of 12. Here they all are. Since the leading coefficient is 1, then it's only going to be plus or minus 1. So these are all the answers that are possibilities. Pause and see if you can find all the possible rational zeros. And here's the answer. Pause, see if you can find them. And here are all the answers. Let's go ahead and see if we can tell the difference between rational roots and complex. So this first is the function odd or even, and the answer is that it is odd. Now how do I know it's odd? Well, because as x approaches negative infinity, f of x approaches negative infinity. As x approaches positive infinity, f of x approaches positive infinity. Since they are different, it's an odd. We have 2 turning points, and if you add 1 to 2 turning points, that's the possible degree. And this looks like it could be a cubic. The number of zeros is always going to be equal to the degree, 3. And in this case, I can see I have 1 real root, so that's 1. And to make these add up to 3, then I'll have 2 complex roots. Okay, this looks like an even root because in behavior is going in the same direction. There are 3 turning points. Add 1 to it. This looks like an 4th degree, and that is an even number. There will be 4 zeros, and it looks like since it's crossing the x-axis twice, I know I'll have 2 real roots, and then to add up to 4, then I must have 2 complex roots. Your turn. And here's the answer. Notice that there are going to be 4 real roots, but one of them is a double root. And you can tell this double root by the way it bounces on the x-axis and doesn't go straight through. Pause. And here's the answer. Notice that there are no complex roots. All 3 of the roots are passing through the x-axis. Okay, let's go ahead and find all zeros. Now I'm looking at this picture and I can see one of my real roots is 4. So I know that x is equal to 4. So I'm going to start with 4 in my synthetic division. So that's going to be 1, -4, 1, -4. I'm going to bring that down 1, 4, 0, 0, 1, and then 4, and then I got a remainder here. So I know f of x is equal to, now when x is equal to 4, we know that this is the factor. So it's x minus 4, and then I'm going to translate this, and this is going to be x squared plus 0x plus 1. So when I want to find the zeros, I'm setting all these equal to 0. And the first one is, I already knew, that was 4, that was back up here, so that's not a new one. So x squared plus 1 is equal to 0. X squared is equal to -1. X is equal to plus or minus root -1. And that means this is plus or minus I. So the three roots, since it's a third degree, the three roots are 4, I, and -I. Okay, let's go ahead and do this. Now, I can see that I have 3 real roots, and it looks like I'm getting a double root. I don't want to go through synthetic division because I see a greatest common factor. So I think I'm going to try this. F of x, and I'm going to factor out an opposite of x squared. And so I'm going to get an x squared, my plus x, and then minus 2. Now, I always like to multiply back out to make sure that I got what I was supposed to. Okay, so then we have negative x times x, and then I think I can factor this one. So it's 2 and 1 plus and minus. So I'm going to get a double root of 0, and then when I set this equal to 0, x will equal to -2, which I see right here. And when I solve here, I get my 1. So I can see all of these. So my zeros are 0, 2, and 1. But this is a double root, which counts for 2. And so 2, 3, 4. I have all my roots. All right, your turn. And I looked at the graph, and I figured 2 and -2 were good things to use for my synthetic division. And then I ended up getting at the very end this. So I'm going to have 2 real roots and 2 imaginaries, and that adds up to 4. Pause. And that looked like a GCF kind of problem. And I get 3 real roots.